Okay, so question 2. The line passes through OR and is parallel to PQ. Calculate the value of X and the value of Y in the diagram. Alright, so first thing I notice is that it tells us that OR is parallel to PQ. So this guy and this guy are parallel. So this means I can, if I have a look here, I kind of have a bit of a Z formation going on here, which means this angle and this angle have to be the same. So I say X is equal to 62 degrees because of alternate angles. Alright, so I have a value for X, now I just have to work out Y. So we should know at this stage that all triangles, if you add up all angles inside a triangle, it equals 180. So my logic there would be that 62 plus 26 plus whatever Y is should equal 180. So Y is going to equal 180 minus 62 and 26. And Y, I've just run out of space, I'll do it up here. Y is equal to 92 degrees. Alright. Part B. So this is a theorem question, and I know this is one of the ones that I think myself and Miss Clonan agreed to mark away from this because you guys haven't seen theorems yet. So we'll just go through it anyway. ABCD is a parallelogram. AE and CF are perpendicular to BD. So AE is perpendicular, so right angle there, and CF is perpendicular to BD as well. Prove the triangles ABE and DCF are congruent. Okay, so let's have a look. The first thing I say is, now it's going to take a while. It's a lot of it's kind of a lot of very wordy. So if ABCD is a parallelogram, alright, then the length of AB is equal to the length of DC. Alright, so I want to prove, if I want to prove that these triangles, alright, this guy and this guy, if I want to prove that they are congruent, I need to either show that all their angles are the same or all the lengths are the same. And I'm going to show that all the lengths are the same. Alright, so let's have a look. We have, if this is a parallelogram, then AB has to equal DC. Alright, so there's one line sorted for me there. Alright, and then the next thing, if AE and CF are perpendicular, so if AE, the line AE and the line CF are perpendicular, I'm just going to use the perpendicular sign instead of writing it out. That's the sign for perpendicular to BD, as this was told in this was given to me in the question. Alright, then BD bisects, alright, bisects the parallelogram, so bisects ABCD. Alright, hence, if this is a bisection, alright, then AE has to equal FC, because otherwise, like, if it didn't bisect, alright, if this wasn't a dead straight line, and it was in any way angled, then these couldn't possibly be 90 degrees. So it stands to reason they must be the same length then. So hence, the length of AE is equal to the length of FC. Alright, so now I've gotten these guys. I've proven that these guys are equal. Alright, so next thing I need to do is try and see about the last one. So triangle ABE, triangle ABE and CDF are right angle triangles, so we know this, they told us that. Alright, with both triangles having two lengths equal. So the triangles have an angle the same and two lengths the same. It stands to reason that the third length must be the same, because otherwise it wouldn't make any sense. Alright, so triangle ABE and triangle CFD are both right angled and have two lengths the same. Okay, so if they have two lengths the same and two angles the same, that's side angle side, so triangles are congruent. Alright, and that's question 2.